Hello, can you hear me?
Good evening, ma'am.
Yes, good evening. Okay, so I think six examples we did in the last class. Today I want to discuss the rest of the examples also before starting with the exercise, right? Now, what does it say? It is saying that the percentage of marks obtained by a student in the monthly unit test are given below. So you can see in one row, it's the unit test, 1, 2, 3, 4, 5. So there are total 5 unit tests, okay? And these are the percentage of marks obtained. Now, based on this data, find the probability that the students gets more than 70% marks in a unit test, right? Yes, Mridula, can you hear me?
Yes, ma'am.
Okay. Now, first of all, write what are the total number of unit tests held? Total number of unit tests. Hello, Miraj. Can you hear me? Yes, Miraj, can you hear me?
Yes, ma'am.
Okay, so I've started the next example. Here, it's a table given to you. These are the unit test held, unit test 1, unit test 2, 3, 4, 5. So total number of unit tests which are held are 5, right? And these are the percentage of marks obtained by the students. Now you have to find the probability that a student gets more than 70% marks in a unit test. Now you can see in the first unit test, the percentage of marks are less than 70. So in a second unit test, they are getting more than 70%, third and not the fourth and the fifth one, right? So total number of unit tests are 5. Now number of unit tests in which this particular student, in which the student has scored secured more than 70% marks. Right? So these are equal to 3. In 3 unit tests, he is getting more than 70% of marks. So you have to find the probability of scoring more than 70% marks, right? This probability you have to find. So write probability of scoring more than 70% marks. So what will be equal to? See, the number of tests in which the student is scoring more than 70% are 3, right? And the total number of unit tests which are held are 5. So 3 by 5 is the probability. Now you can convert it into decimal. So this will be like 0.30 means 6. 0.6 is the answer. Is it okay?
Yes, ma'am.
Okay. Next question. Okay. This is the question now. Now try to understand the table first of all. An insurance company selected 2,000 drivers at random. So the total number of drivers are 2,000. You can just note it here. Now, without any preference, okay, in a particular city to find a relationship between age and accidents. So this is the data which is obtained. Now try to understand this. So this is the age of drivers, right? From 18 to 29 years, then 30 to 50 years and above 50 years. Now these are the accidents in 1 year. Uh, so this 0 means 0 accident, right? So basically in this age group, 440 drivers have not done any accident, right? And
Yes,
one
ma'am.
and 110 drivers have done 2 accidents in 1 year. It's like that. Is it clear now?
Yes, ma'am.
Okay. Now come to the question. Find the probability of the following events for a driver chosen at random from the city. Now, first one, being 18 to 29 years of age and having exactly 3 accidents in 1 year. So basically, see this column, 18 to 29, and exactly 3 means this. So how many drivers are there? 61,
Ma'am.
right?
Yes, ma'am.
Okay. So first one, um, so first of all, you have to mention the total number of drivers. So you write number of drivers. You cannot directly write because you have to write something. First of all, write a sentence and then don't do it directly, right? So number of drivers uh, in the age group 18 to 29 and having exactly 3 accidents. Exactly 3 accidents. So basically you have to write this complete line, right? Which is given in the question. This line I'm writing. So how many drivers are there? 61, right?
Yes, ma'am.
So now find the probability. So probability that the driver is like 18 to 29 years, like it falls in this group, and with exactly no, don't write and, with exactly 3 accidents. So basically this probability we have to find. All right. So the number of drivers are 61 and the total number of drivers are how much?
2000.
2000. Yeah. So out of these 2000, only 61 have a fall in this category. So this is the probability. Now you just, can you divide it? Should I leave it? Okay, I'm leaving the calculation for you. You can complete the calculation, right?
Yes, ma'am.
Fine.
Ma'am.
Now come to the second part. Being 30 to 50 years of age, right? So this column you have to see, and having 1 or more accidents in a year. So 1 or more. So you have to include 1 or more, right? So basically we are going to add this 125 and this. Is it clear, Miraj?
Yes, ma'am.
Yeah. So there, then only we are going to get the total number of drivers. So first of all, write the total number of drivers. Number of drivers in the age group 30 to 50 years having 1 or more accident. So this will be equal to, now you have to add. So 125 plus 60 plus 22 plus 18. Is this point clear? Because it is saying 1 or more, right? So you have to include 1 and the rest of the other cases also. Now please add it. What will you get? Yes, Amna, tell me, what will you get?
Ma'am, 225.
225. Okay. Now find the probability. So the probability that the driver is 30 to 50 years, 50 years, having 1 or more accidents. right? So this will be equal to 225 and divided by total number of drivers are again 2000. So just find the answer. I'm leaving it for you, right?
Okay, ma'am.
Okay. Now the third one, having no accident in 1 year. So first of all, write the number of drivers having no accident. So how much will it be equal to? See the table here. Yes, Miraj, you will tell me. What should I write? Number of drivers having no accident in 1 year. How many drivers are there? Yes, are you there, Miraj?
Ma'am.
Yes. So what should I write? Like how many drivers have are having no accident in 1 year? Now here, see, he is not talking about the age of the driver. He is simply saying, see the third question, having no accident in 1 year. So there is no mention of age. The driver can fall in any of the age group. So what should I take here? What is the number of driver having no accident? Oh, taking so much of time. Now see this, 0, right? So this column is telling you the number of drivers which are having 0 accidents, right? Now, since in the question the age is not given, so basically I have to take all the age group. I'll have to add these three, isn't it?
Ma'am.
Yes?
Yes, ma'am.
Yeah, because he is not saying about a particular age group. He is simply saying no accident. So that is why I have to take in this age also, and this age also. So first of all, I'm going to add it. So this is going to give me the number of drivers having no accident. So write 440 plus 505 and plus 360, right? So what will I get, Mridula? Tell me.
Ma'am, 1305.
Okay, 1305. Fine. So just find the probability. Probability of driver having no accident. So this will be equal to 1305 and divided by 2000, and you will do the calculation, right?
Okay, ma'am.
Okay. Next question. I think there is only one exercise in this chapter. This is not a long chapter. And it's easy. Like once you understand, it's easy to do, isn't it? Okay, so in the next example, you have to see the frequency distribution table, which is given in the chapter number 14. So I'm just leaving this example for you. You can just open your chapter number 14 in your group and see table number 14.3, and that table you have to use in this question. So I'm just coming to example number 10, right?
Okay, ma'am.
Yes, this is the question. Now, 50 seeds were selected at random from each of 5 bags of seeds, okay, and were kept under standardized conditions favorable to germination. After 20 days, the number of seeds which had germinated in each collection were counted and recorded as follows. So basically, in the question, they have taken 5 bags, bag number 1, bag number 2, 3, 4, and 5, right? Now, in each bag, the number of seeds which have germinated are as follows. Can you see this?
Yes, ma'am.
Okay, so basically 50 seeds they have taken, and out of 50 in the bag number 1, only 40 have germinated. In the bag number 2, 48 have germinated. It's like that. Is it clear? Okay. Now, what is the probability of germination of more than 40 seeds in a bag? Right? So this 1, 2, 3, 4, 5 are basically the number of bags. So you see this number of seeds germinated, this line. Now more than 40 seeds in a bag. So more than 40, you don't have to include this, right? Because this is exactly 40. Yes, Miraj?
Yes, ma'am.
So do it carefully. In the question, it is given more than. So more than 40 means bag number 2, bag number 3, and bag number 5, right?
Yes, ma'am.
So in how many bags 40 seeds have germinated? So in how many bags is it happening? 3 bags, right? And total number of bags are how much? 5. Okay. See, in this question, look carefully. Some data is given just to confuse you here. Like 50 seeds are given, but basically you are finding the probability of germination of more than 40 seeds in a bag, right? So basically he is talking about the number of bags, like in how many bags is it happening, right? So in 3 bags is it happening, and the total number of bags are 5. So the probability of what? Germination of more than 40 seeds, right? More than 40 seeds. This probability you are finding out, or in a bag. So this is equal to, in 3 bags is it happening, and total number of bags were 5. So 3 by 5 is the probability. Just convert it, you will get 0.6 in decimal. Okay. Now second part. Yeah, any confusion to anybody, please ask me at this point only.
No, ma'am.
Okay. Now second, 49 seeds in a bag. So exactly 49. So is there any bag which is having exactly 49 seeds which have germinated? Yes, Miraj, is there any bag in which is it happening? Yes, Miraj, can you hear me? Say yes or no.
Yes, ma'am.
Yeah. So he's saying 49, yani exactly 49 seeds. Can you see any bag in which exactly 49 seeds have germinated in this data? Oh, it's not such a big data,
No, ma'am.
Miraj. Yeah. So 0, right? It's
Yes.
happening like in none of the bag is it happening. So 0. So the probability of having 49 seeds in a bag is basically 0 by 5, which is 0, right? Okay, now third, more than 35 seeds in a bag. Now more than 35. So in this bag also, right? In this bag also, this bag also, this bag also, and this bag also. Like in all of the bags, the number of seeds which have germinated are greater than 35, right?
Yes,
So
ma'am.
first
Yes,
of all,
ma'am.
find the number of bags having more than 35 seeds or germinated seeds. So this is exactly 5, right? So in this case, the probability will be of more than 35 seeds in a bag. So it is happening in 5 bags, and the total number of bags are also 5. So the answer is 1, total probability. Right?
Yes, ma'am.
Okay. So the examples are over. Let us start with the exercise now. Let me just open the exercise. Okay, so this is now your exercise 15.1, right? Now, in a cricket match, a batswoman hits a boundary 6 times out of 30 balls she played, right? Find the probability that she did not hit a boundary. So, first of all, total number of balls are how much? Total number of balls which she had played. She has played 30 balls, right?
Yes, ma'am.
So, number of balls in which she has hits a boundary?
Ma'am, 6 balls.
6. So these are equal to 6 balls, right? And you have to find the probability that she did not hit a boundary. So first of all, you have to find the number of balls in which she had not scored a boundary. Yes, Mehraj?
Yeah.
So number of balls having no boundary. How you will find out?
Ma'am, 30
Ma'am,
minus
30 minus 6.
Very good. So total number of balls she has played 30, and in 6 she had scored a boundary. So that means in 24 balls there is no boundary. There is no boundary. Yes. Yeah. Now find the probability. So the probability of not hitting a boundary. So this is equal to 24, and total number of balls are 30. So this will become how much? Like 8 by 10, and this is again sorry, 4 by 5, yeah, and this is 0.8. Yes. Okay, please note it down. Then I'm doing the next question. Yes, done.
Yes, ma'am.
Fine.
Yes, this is the table. Now see, 1500 families with 2 children were selected randomly, right? And the following data were recorded. Number of girls in a family. So, and these are the number of families. So basically the data means in 475 families, there are two girls, right? In 814 family, there is only 1 girl, and in 211, there is no girl in the family, right? So this is the data. Understood?
Yes, ma'am.
Okay. Now compute the probability of a family chosen at random having 2 girls. So first of all, you have to write the number of families which are having 2 girls. And what are the total number of families? First write what is the total number of family. Yeah. Total number of families are how much in this question?
Ma'am, 1005.
475.
No, 1500 families. Yeah. I mean, this
Yes,
data
ma'am.
is about 1500 families. So this is the total number of families, 1500. Now come to first question. Number of families having 2 girls. Having 2 girls. How many families are having 2 girls?
Ma'am,
Ma'am,
475.
475. Okay. So you have to find the probability that the family is having 2 girls. So the probability of having 2 girls. So 475 families are having 2 girls and the total families chosen are 1500. So this is the answer. Yeah. What will you get? Tell me. Do the calculation quickly. Okay, in your NCRT book, if the answer is given in fraction, you can leave it in fraction. But tell me, what are you getting here?
Ma'am, I'm getting 90 upon 60.
9, sorry, 9,
Ma'am,
1, 9,
9. Ma'am, 19 upon 60.
60, 19 by 60. Okay. Okay, I'm leaving it in fraction then.
Ma'am, in the
Hmm,
sheet, ma'am, answer sheet is also given in fraction.
fraction. Okay, fine. Now, second part. So you have to find the probability of having 1 girl. So again, same question. Number of families having 1 girl. Yes, Miraj. How many families are having 1 girl? Yes, Miraj.
814.
Yes, 814 families. So the probability of having only 1 girl in the family, 1 girl, sorry, not S, 1 girl is equal to, so 814 families and total family chosen are 1500. Now tell me, what are you getting, Hamna? Yes, Hamna, what are you getting here? Tell me. Okay, anybody tell me?
Ma'am,
Ma'am,
0.542666 something.
Oh, okay, now tell me in fraction, what are you getting?
Ma'am, 407 divided by 750.
407 divided by 750.
Yes, ma'am.
Okay, can this be divided further?
No, ma'am.
Sure.
ma'am, in the answer sheet, it is also given in fraction.
Okay, then fine. Third part. Now having no girl. So write number of family having no girl. having no girl. Okay, how many families are having no girl? 211 family. So probability of having no girl, this is equal to 211 and divided by this 1500. Now also check whether the sum of these probabilities is 1. So you have to do your check here. So is it in simplest form? Can this be divided? Okay, anyway, you have to do your check. So you have to do the sum of all the probability, 9 by 60 plus 407 divided by 750 and plus this 211 and divided by 1500. Yes, so how will you add it? Miraj, what is the method of adding fractions? What is the first step now? What will you do? Yes, Mridula, how do you add fractions?
Ma'am, we will take LCM of the denominators.
Exactly. So when you want to add or subtract fractions, first step is to take the LCM, right? So should
Yes,
I
ma'am.
do it or should I leave it for you? Okay, let's do it. So 60, 750 and 1500. Fine. 60, what is it? What is the other one?
ma'am, 750.
750 and 1500. Okay. 750 and 1500. Okay. Now find the LCM. So if I use the table of 5 here, so 5, 1, 12, right? 5, 1, 25. Now 3 into 4 and 3 into 5. And now I think which table I can use here? 2. This is 25 and this is 50. Again 2. So 1. And this is 25 and this is again 25. So now 5. Am I right? Am I doing it correct? Yeah. Is this right? This is 2.
Ma'am.
Okay. So now you multiply this. What will you get? 5 into 3, 15 into 2, 30 into 2, 60. 60 into 5 is 300 and 300 into 5 is 1500. So my LCM is 1500, right? So here, the LCM has come out 1500. Okay. Now, how many times will it go in 60? Divided by 60. So 6 into 3, 6 into 2 is 12 and 30, 25, right? So 25 into 19 I'll get here. And 750 into 2. So 2 into 407 and plus 211. So now multiply 25 with 19.
Ma'am, 395.
395. Okay, 395 plus this is 4 into 7 is 14 and 804, right? 211 and divided by 1500. Now please add the numerator. So 5 and 5, 10, 0, carry 1, 2, 3 and 10. Yeah, what I'm getting?
Ma'am, I'm getting 1420.
1,
420.
1420 divided by 1500. Okay. So this is not equal to 1, right? What is given in your NCERT book? Yeah, is there something given in your book?
No, ma'am.
Okay. So fine, in my case, it's not equal to 1. Right. Now, next question.
Ma'am, it is less than 1.
Yes, it is less than 1. I mean, not exactly equal to 1. Because the numerator is small. Yes, Miraj?
Yes, ma'am.
Okay. Now, next. Okay, for the time being, I'm leaving question number 3 because in this I require the screenshot of your chapter number 14. So I'll take it in the next class. I'm coming to question number 4 now. Now, this is the question. Now, 3 coins are tossed simultaneously 200 times with the following frequencies of different outcomes. Now, first of all, try to understand the possible outcomes. You are having 3 coins. Yes, Miraj?
Yes, ma'am.
Yeah, 3 coins are there. Now, every coin has a head and a tail. Yes?
Yes,
Okay.
ma'am.
So you are tossing it simultaneously. So there can be like number of cases can be there. In first case, every coin might have head, head, head. Yes. Or it can happen that 2 coins are having head and 1 coin is having tail. Yes. Then it can happen that only 1 coin is having head, the other 2 are having tail. Yes. And then all the coins are having tail. Yeah.
Yes, ma'am.
Yes. So there can be different cases. Try to understand this thing. Now, in the question, try to understand this table. So the outcome 3 heads. That means every coin is getting a head, head, head. So this case is happening how many times? It is happening 23 times, right? We have tossed 200 times. We have tossed the coins simultaneously, and 23 times it is happening that all the coins are having 3 heads. Then 72 times it is having that 2 heads are there. 77 times only 1 head is coming, and 28 times no head is coming. That means all tail, tail, tail. Is the table clear, everybody?
Yes, ma'am.
Okay. Now, which probability you have to find? If the coins are simultaneously tossed again, compute the probability of 2 heads coming up. How will you do it? Tell me. Right, the total number of tosses first of all. How many times you have tossed?
Ma'am, 200.
200, right? And what will you write? Like number of times getting 2 heads, right? So number of times getting 2 heads. How many times you are getting 2 heads?
72.
72.
72. Yes. So you have to find the probability of getting 2 heads. So this is happening 72 times. Total tosses are 200. This is the answer. Now you just simplify this. Okay, use the table of 2. So 2 into 3, 36 and divided by 100. So this is going to give you 0.36, right?
Yes, ma'am.
Yeah, or you can do it in like fraction also. Only this much is there in this question. Okay, next. Okay, it's a long question. Wait. Now try to understand this. An organization selected 2,400 families at random and surveyed them to determine the relationship between income level and the number of vehicles in a family. The information gathered is listed in the table below. Now, this is the monthly income of the family in rupees. So, less than 7,000 rupees, then 7,000 to 10,000, like that. Okay. And these are the vehicles per family. So, basically, like the families which are having less than 7,000 income, monthly income, so 10 families are there, they have no vehicle. Yes. And 160 families are there who are having one vehicle in a family, and only 25 families are having two vehicles. It's like that. Is it clear?
Yes, ma'am.
Now you have to find, suppose a family is chosen. Find the probability that the family chosen is earning rupees 10,000 to 13,000 per month. So which category you have to look here? This one, right? And owing exactly two vehicles. Exactly two means this data, right? Yes, is this clear? First of all, write the total number of families in this case. Surveyed. So on how many families the survey is done? 2,400 are the total number of families, right? Now first part. Number of families having income of rupees 10,000 to 13,000 per month, and owing exactly two vehicles. So how many families are there?
Ma'am, 29.
29. Yes, Miraj?
Yes, ma'am.
Okay, so you have to find the probability. Probability of, again, income rupees 10,000 to 13,000, having two vehicles, right? This probability you have to find, which is 29 and divided by this 2,400. So I'm leaving the calculation part for you. Second, earning 16,000 or more per month and owing exactly one vehicle. So 16,000 or more. That means here you have to see. Yes. See, if you guys remember in the previous chapter of statistics also, there is one thing I told you, if you remember. Now look here carefully. The 16,000 is coming here also. It is coming here also. So where will you count it?
Ma'am, the last one.
Last one. Yes, Miraj, if you remember?
Yes, ma'am.
Yeah. So this 16,000 or more he is saying. So we will not look at this 16,000. We will look, this 16,000 is included here, right? So basically this column, this row you have to see. And so you will do it, okay? Now earning 16,000 or more per month and owing exactly one vehicle. So exactly one vehicle means number of families are how many families are having? 579 families are having this. So can you find the probability now? Or should I
Yes.
write it? Yes, should I write it? Miraj,
Yes,
Mridula,
ma'am.
should I write it or will you do it?
No, ma'am, I'll do it.
Okay. Now next part. So second, I'm leaving for you. Exactly the same way you have to do, right? As the one. Third part. Earning less than 7,000 per month. Okay, less than 7,000. So the 7,000 will be included here. Yes? So less than 7,000 means you have to see only this row. Is this point clear?
Yes, ma'am.
Yes, Hamna?
Yes, ma'am.
Okay. Miraj, see, he is saying less than 7,000. So in the case of statistics, we will not include the 7,000 here. We will include it here. Yes? So basically this 7,000 is fall in less than 7,000 category only. Is this point clear?
Yes, ma'am.
Okay. So see this, this row you see, and does not own any vehicle. That means this you have to see. So how many families are there? 10. Yes? Yeah. Is this okay?
Yes,
Yes,
ma'am.
ma'am.
Okay. Okay, let's write. Number of families earning less than rupees 7,000 per month and having no vehicle. So this is equal to 10. 10 families are there. So what is the probability? You can simply write probability like this also, okay? If you don't want to write everything in the bracket again, because you have already mentioned here. So probability is simply 10 and divided by how many families are there? 2,400, right? So
Yes,
this
ma'am.
is the answer. You will do the calculation. Now fourth part I'm doing. Earning 13,000 to 16,000 per month and owing more than 2 vehicles. Now see this carefully again. Now let me erase it. Now look at this clearly. Earning 13,000 to 16,000. That means this row you have to see. And owing more than 2 vehicles. So 2 vehicles are this. More than 2 means you don't have to include 2 vehicles, isn't it? You will only see this, more than 2. Is this point clear?
Yes,
Yes,
ma'am.
ma'am.
So how many families are having? 25 families are having this. I'm just writing here 25, right? So the probability is 25 divided by 2,400 that you can write. Now see, owing not more than 1 vehicle. Okay. Now see the last question, last part. Here the income is not mentioned. He is saying owing not more than 1 vehicle. So basically you have to see in every income group. Yes. And not more than 1. So you have to see this also, like 0 also and 1 also, not more than 1. Is this point clear?
Yes, ma'am.
Yes, Miraj, is this point clear?
Yes, ma'am.
Okay, so basically you are going to add all these numbers. I mean, you will add these all and you will add these all and then you will add them. So these like all these families you have to include in this group, right? Let me write the last part. Number of families owning not more than 1 vehicle. So this will be equal to you can see in your table. I'm just looking at the book. I think 10 plus, then you have 0 plus 1 plus 2 plus 1. Yes. And then second 160 plus 305 and then plus 535 plus 469 and plus your 579. So all these families you have to add. So what will you get here? Quickly tell me, what are you getting here?
Ma'am, 2062.
Again say, Hamna.
Ma'am, 2062.
2062, right? So the probability will be equal to 2062 and divided by 2400. So you will do the calculation here. Yes. Do you want to do the next question also? Okay, let's take up one more question. Okay, for question number 6 also, you have to go to your previous chapter. So I'll take it in the next class. Let's do question number 7 now. Okay, this is the question number 7. To know the opinion of the students about the subject statistics, a survey of 200 students was conducted, right? So this is the data obtained. Out of 200 students, 135 students basically like statistics and 65 students dislike statistics. Is this table clear? Now find the probability that a student chosen at random likes statistics. So what are the total number of students for this data?
Ma'am, 200.
200. Total number of students surveyed, on which this survey has been done, which are 200. Okay. Now, first of all, you have to find the number of students who like statistics. So first part, number of students who like statistics. How many students are there?
Ma'am, 135.
135, yes. And so the probability of what you are finding out of liking statistics, or the student like statistics, you can write like that. Student like statistics. This probability you want to find out. Okay. So this is 135 students are there and the total surveyed are 200. You will do the calculation. I'm leaving. Then second, does not like it. So this data is already given. Otherwise, you could have subtracted it from 200. So number of students who dislike statistics or does not like statistics. This is already given in the table, which is 65, right? So probability that a student dislike statistic. This will be equal to your 65 and divided by 200. Yes?
Yes, ma'am.
Okay. Okay, then I'm leaving it here today. The rest of the questions we will take up in the next class on Monday. And I think only one chapter of construction is remaining. Yes?
Yes, ma'am.
Okay. Okay, that we will do. I'll take up the chapter. I'll switch to I'll like share video for that, that way I'll be able to do the construction. Okay, then let's meet on Monday at 9:30. Okay, bye.